Colonial siphonophores. They are deep-sea marine animals related to jellyfish and corals. These are colonial organisms, meaning that they consist of multiple genetically identical individuals called zooids. Together, they function as one whole organism, forming a long, fragile chain of individuals, with each zooid being responsible for its own task. While neurons are not exactly the same as this, they do take on a similar shape, which is why I have chosen the siphonophore and its many zooids to represent my neuron. A neuron consists of mainly 6 notable parts. The dendrites, represented by the nectosome, are a short branched extension of the nerve cell, along which impulses received from other cells at the synapses are transmitted to the cell body. They also determine whether or not the neuron will fire an action potential depending on the inputs it receives. The cell body, or soma, represented by the pneumatophore, is the central part of the neuron that contains the nucleus and other cell organelles. The cell body itself creates a nerve impulse that tells the cell to prepare to fire an action potential. The axon, represented by the stem of the siphonophore, is the long part of the neuron that transmits signals, including action potential, away from the body to other cells. The myelin sheath, represented by the palpons on the siphonophore, are the insulating layer that wraps around the axon. It increases the speed of the signal transmission between neurons. The neurotransmitters, represented by the reproductive polyps, are chemical signals released by the synapses to be transmitted to other cells. These chemical signals are the action potential themselves, essentially translating information into usable format from one neuron to the next. Finally, the axon terminals, represented by the feeding polyps, are the endings of the axon that release neuron transmitters to the other cells. I still don't know how to end videos, so bye.